Okay, we will start on stage 2, and Allar will be talking about unleashing the crowd. Please.
Hello everyone, my name is Allar Lauk, and I wanted to ask you a question. Is anybody else feeling it? Like that the relentless pressure as your product attack surface is expanding, but your security efforts just can't keep up? It seems like an impossible task, especially considering limited resources. But what if we didn't have to fight it alone? What if we could leverage a global set of allies to help us secure our defense? That's what this talk is all about. By the way, has anybody heard of Bolt? Well, if you're Estonian, then you probably yes. But if not, then here's the gist. Basically, it's a platform for mobility and delivery service. We have 5 core products: ride, rental, car sharing, aka drive, delivery, and market, which is grocery delivery. So, but before we begin, let's see where we are right now. Can I get a show of hands? How many of you are working in cybersecurity? Okay, see a lot of hands. That's great to see. Looks like I've come to the right place then. So, here's a little bit about me. I'm a cybersecurity engineer in Bolt, and I work for a product security team. I mainly work with vulnerability management, and I'm here to share our lessons from the trenches. So, discussing about our experience with crowdsourced security. And also, most importantly, I have a dog named Melly. So, let's start with the problem and try to understand where does crowdsourced security fit into the security toolbox. So, the problem. Working in a fast-growing company means that everything is constantly changing. There's reorgs, new features, new endpoints, new attack vectors. This means that the attack surface is constantly growing. And security teams are always left playing catch-up. So, okay, that kind of sucks, but surely that means that the teams responsible for keeping these systems secure are also expanding at the same pace, right? Unfortunately, no. The reality is that security teams have to make do with a lot of limited resources. So, for example, our product security team is very small, and we like to think in the long term. So we want to build scalable systems which help our future move forward. But that means that we lack the capacity for deep and narrow focus, which is required for every application and the service. So we're constantly asking, what is the most important and feasible security problem that I am capable of solving right now? And the sub-question would be, is doing activity X better than activity Y to solve our problem? And this is like a constant cycle. So we gotta ruthlessly reevaluate and pick our battles. And what happens if we have constantly growing attack surface and limited resources? We get blind spots. And these blind spots are constantly growing. combat these threats. So what can we do? Well, let's start with option A. So option A, shifting left. We could delegate security testing to feature dev team. After all, they are the most knowledgeable about the feature, and it probably means that this is really efficient and helps us with saving with costs. So, but it's clear that the feature dev team is really adept at usability and functionality and performance of the feature. But is it the same with security testing though? Maybe, maybe not, because most feature development teams lack specialized security expertise, which means they need a deep understanding of vulnerabilities and also how to exploit these in a given environment. Also, testing is mainly focused on intended functionality, and this means that security testing is often kind of forgotten or just deprioritized. And also time and resource constraints. So as we already mentioned, feature dev team's main goal is to create a usable feature or application within a reasonable amount of time that fulfills all business requirements. That's the main goal. But the attackers are not limited by this deadline, not at all. So they have all the time in the world to explore all of the whole ecosystem, and their goal is to find and exploit vulnerabilities to subvert the program application's intended purpose. And finally, there's limited scope and tooling. So there's a limited amount of time to do the features, and as we talked, security testing usually does not belong there. About tooling, security tooling requires quite a lot of expertise and also knowledge about how to use them and the vulnerabilities, and also they often require a business license, which means that they need to get a team and everyone needs to be on board, or else it will be considered a non-essential cost, and meaning that the feature dev team can't use it. Okay, so what else can we do? Well, option B, let's try hiring internal pen testers. Let's see where that gets us. So, an internal pen tester will develop a deep and continuous knowledge base, which will have very strong understanding of company systems and architecture, which is great. Also, it creates a seamless collaboration between the developer team and the information security team. And the strategic focus. So the internal pen tester will develop a strategic focus which helps identify systemic weaknesses. But there are some cons. First of all, it's a high cost, because hiring a full-time talented employee is often more expensive than just doing a project-based external pen testing. Then it is not a scalable solution. Yet again, because of the high costs, and also the results are very dependent on the subject's skill set. So let's discover some more options. We already briefly touched on pentest providers. Let's see about that. So pentest providers have highly specialized expertise when it comes to testing, and also they provide an independent assessment, which is fantastic. Also, they're available on demand, of course, so you can just schedule when you want this application to be tested, and they will do it. But the cons are that it's time-boxed. So again, there's a limitation of time, which means that the testers are often incentivized to find something rather than do deep exploratory testing, which is very time consuming. So also they have lacking contextual knowledge of the whole system, which means that they have a hard time finding complex chains of vulnerabilities, and therefore it is hard to demonstrate, for example, impact. And also they're restricted to a very specific scope, and they have to work within this scope or else they will breach the contract if they go out of this. So I guess this means that they have to be pretty careful. So it's like they can't do what they want. And also it offers just a brief snapshot in time. So, and what's the last option? Let's try using the crowd. Enter crowdsourced security. So crowdsourced security has various types. So there's VDP, or Vulnerability Disclosure Program, Bug Bounty Program, aka BBP, and crowdsourced pen testing. We at Bolt have implemented it through Bug Bounty Program, which gives us access to global and diverse expertise of skilled researchers, which is that we get like unique attacker mindsets from all over the world. It is continuous and always on, so yeah, basically 24/7, no time constraints. Also, it's very cost effective because you only pay per results. It's a very cost efficient model in that sense. And it is rather scalable because if you add more features, then you can just invite more people in testing, and that kind of evens it out. So in very simple terms, how does a bug bounty program work for the company? So a company signs up to be a bug bounty provider, defines the engagement, rules, scope, targets, rewards, launches the program, gets vetted hackers to start testing the engagement. Findings will be first triaged by bug bounty program provider, and if it's passed, then it's passed on to the company for the second level triage. And if it fails, then it's not redirected to the company. And valid findings will be eligible for a payout from a company's prize pool and delegated to the responsible development team. Pretty simple. So where does bug bounty program sits in the reporting flow? It's right here. And the important bit is that it has to be before your ticket management system to ensure a logical flow of information. So yeah, you get the input, you get first level triage, and if it passes, it gets second level triage. Nice. So let's talk our strategic integration. So let's say you find an issue. What do? You Google vulnerability report Bolt, right? And first link that pops up, public vulnerability reporting policy page. You skim through that, yada, 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 and you find security email. So you message the security email. What happens then? This is a manual decision-making point. So depending on a variety of factors, such as time of day, workload, perceived priority, it will either get pushed to Jira, our ticket management system, or directly to the product security team without bypassing ticket management system. Sometimes it gets added back in, sometimes not. And also important thing to note, if you have to do this manual decision a lot every time, when your organization gets bigger, you will get a constant volume of these submissions, and it will become a bottleneck really quickly. Okay, so let's say we started our crowdsourced security program. We set the public vulnerability reporting policy. We set up a security email and a private bug bounty program with bug crowds. So this is how the setup looks on the bug bounty program provider side. We set up a single simple engagement brief. We expect no concrete formatting from the bug bounty reports, and there's no clear process for handling reports. So this is how this will kind of look like. So yet again, you're here, you found the vulnerability, you go to security email, and you have to make this manual decision again, which, as we described, the outcome may vary significantly. And now there are even more decisions to make, because you have three options basically now. You can create a ticket to Jira, or you can invite the researcher to your program. So first, that's the first decision. Or there's a third option as well. It can go secretly directly to a product security team. So this is obviously not a very logical flow. And also there's a second manual decision-making point. So a lot of cognitive overload is possible. And you have to do this every time, so it's a lot of wasted decisions. What are the results of this? So, as I discussed, there is a lot of operational overhead, which means that making optimal decisions is rather difficult, and it significantly contributes to the decision fatigue. So that makes it hard to prioritize, because there is no clear flow of information, which causes confusion. And it becomes really apparent when you have to start tackling the backlog, believe me. There's also inconsistent report quality, because there are so many different sources of input, and there's no expected format, so that's a recipe for disaster. And finally, vulnerability databases are not in sync. So since you had to make so many manual decisions, bug crowd might have more submissions or differently worded, and your Jira might have differently worded or not documented at all. So the learnings are, we have to automate to remove overhead. We have to improve the funnel. We have to incentivize good formatting, because this is a win-win-win scenario. Because if you create a good format, then you teach the security researcher for how to submit good reports and increase their chances of a payout. On our bug bounty program provider side, it is good because it's easier to triage, and for us, it means that less noise gets through. So yeah, all three parties win. And the fourth learning is that we consult with our bug bounty program and improve the scope as needed. So identify and implement actionable steps to better identify duplicates, etc. So after applying the learnings, we make the changes, which is to revamp the engagement brief. We turn the private bug bounty program to public. We set up a security email autoresponder, and we set up auto-syncing in bug bounty provider. So this is how the setup v1 looked like, and this is how setup v2 looks like. As you see, it is much more logical now, because autoresponder redirects to bug route, and so everything will go there. It means that we leverage their program as much as possible, and if it passes the first level the triage, then it will be linked to Jira, which means there's a much more logical flow of information. Results? Well, significantly reduced overhead. It's easier to make optimal decisions, and there's less decision fatigue. And there's also higher signal to noise ratio. because almost every triaged report will now include a working proof of concept. And higher quality reports means it's easier to triage. And yeah, already covered this. There is a single up-to-date vulnerability report database, which is great. We can be quite sure that it contains all valid issues because it's always synced. So, roles of these different methods in our security team's toolbox: shifting left finds and fixes low-hanging fruits before they ever reach production. This is a continuous work in progress as we're providing and building the tooling that they can use. So, internal pen tester provides continuous and deep in-house knowledge, and we hired it, but the responsibilities changed because we were building stuff. External pen tester delivers an unbiased audit report of a specific part of the app. We have that. And the bug bounty program, which leverages global hacker community to identify vulnerabilities composing of complex attack chains, which we also now implemented. So let's talk some triumphs, challenges, and actionable intelligence. So here are the triumphs. We have found some quite interesting findings. Basically, the first one is about how to get the free pass, so get free rights, which is basically, happened because the security researcher discovered that he could manipulate HTTP headers and change the price before buying the pass. And of course, our server was like, oh, that's fine, there's no validation, let's do it. Then the second issue, there's a payment bypass which allowed for free food, which was basically tied to our customer support refunding system, which happened where if you made a purchase and it was delivered to you, you could then ask for a refund, remove one item from the list, and it thinks that it takes that one item off the list, but actually it provided a complete refund. So that's fun. And also there's a one-click account takeover, which was a pretty complex attack chain. Basically, there was a deep link which could contain arbitrary payloads, and the security researcher was able to find out a JSON payload which basically created a fake window within the app which looks very legitimate, and it contained the CTA button, and there's no CORS policy. So basically you could send a post request to attacker C2 server and get like authorization headers, which is not ideal. But this also is a fantastic find by the security researcher and a perfect example of when a bug bounty program can provide you value. And the last one is unlimited remote scooter ringing, which basically means that you could make any scooter in the world ring at any point in time for unlimited time. And there's a working proof of concept to show you that. So I present to you a symphony of the scooters. Yeah, so normally there should be like a free ring limit, but since the endpoint was suddenly changed, the rate limit was forgotten, and that's the result. So we discussed triumphs. Let's talk about the challenges. So it is significantly reduced, but there is still significant amount of noise. Which means that non-issues are portrayed to be really significant, and issues reported to us are instead caused by third-party providers. So just a few examples. There's also inevitable challenges of multi-party triaging. So on our bug bounty provider side, there's like a lot of security researchers who constantly switch, and so it means that at any point in time there's a different triager, and that means that the results can vary significantly. There's inconsistent report volume, which can catch triaging teams off guard if they're not prepared for it. And finally, there are unpredictable costs. Now, I know we discussed that these are low cost, it's a positive, but you have to consider that the price pools which are made are usually created on the amounts that the average payout is done in some certain amount of time. And most findings are either low or medium, so they have much smaller prices, rewards. But if you happen to have a couple high or critical findings which have like payouts that are 3 to 5 or even more times larger, then it can like just drain the price pool instantly. Okay, let's talk a little bit about actionable intelligence. So how to go from findings to strategy. You have to start and documenting and grouping your findings. So you can use this data to identify systemic weaknesses. You can use grouping per vulnerability type, business vertical, service, team, or whatever makes sense to you. Then you have to evaluate and prioritize. You have to identify the most pressing but yet solvable issue at this point in time. And you have to create a plan and take action. So some examples of action would be, in case there are a lot of web vulnerabilities, you might provide training to the developers on OWASP Top 10, for example, or make a training for secure software development lifecycle. You can also create some tooling, which devs use by default to eliminate any kind of friction and also eliminate classes of problems at the same time. Such as, for example, if you have hard-coded secrets, you can use like a secret scanner such as TruffleHog, which would run on every PR and would block if it contains secrets. Let's discuss a little bit about how to get started in when you consider a bug bounty program. First things first, choosing a vendor. As always, you should do your research, and you should connect all of the bug bounty provider vendors who you know, which interest you, and ask about various topics such as program management. For example, do you have a private and public, or just private or just public? Also, how does your platform handle triage? And how does the communication with relevant parties act on your platform? You should also ask about research community. How do you vet and make sure that the security researchers are legit and not like some black hats? You should also ask about possible integrations and reporting capabilities, such as what native integrations you have, like do you have integrations to Jira or messaging applications, webhook capabilities, all that sort of stuff. And also you should ask, of course, about security and confidentiality of data, which means how do you ensure that my data on your platform is secure? How do you do that? And what procedures are in place that help you protect this data? And also, of course, you should consider pricing. So on top of bounties, you should consider what kind of other fees there are associated with the platform. And also you should ask how can you help manage our costs so that it won't go out of control. So, and you choose what works for you. For us, it turned out to be bug crowd. So how do you decide between private and public engagements? Generally, if you're starting out, go with private because you have more control over who gets access and can control the amount of participants in your engagement. Also, there are less submissions, so it means that you won't get instantly overwhelmed by a sudden influx of reports coming in. And you should consider making the engagement public if you've already ran the private program for a while successfully. You are ready for a large increase in submissions, and you have confirmed with the bug bounty provider that this is the right way forward. So, some tips for success from our experience, that is. Continuously work with your provider and highlight issues. So, that is the best way to make sure that these issues are fixed. You should create detailed terms of service to enforce when needed, meaning that the security researchers sometimes go out of hand and start typing in all caps and demanding everything. So if you have clear terms of service, you can enforce it easily. Also, you should keep an updated list of in-scope and out-of-scope items, because these bug bounty providers, they will check against it every submission, so it will help them with triaging a lot. You should also simplify your reporting flow as much as possible, because this will remove the constant decisions you have to make, so you can make higher quality decisions overall. You should also create an operational checklist to criteria to check, because it saves you time when triaging, a lot of time, and also it helps keep you sane if you have a large backlog of items which you have to go through. So, some concluding thoughts. Security works best in layers, and consider this: a bug bounty program is not the replacement for other methods. But you can also, you don't have to fight alone. You must know that, and consider a crowdsourced security as a valuable tool in your security toolbox. Crowds finds what others miss. Because it's a global mind, you get very different unique attacker mindsets, which means that they are able to find very different types of vulnerabilities. Sorry? And also, Crowd helps you transform your vulnerability management by creating data through vulnerability reports, which help identify systemic weaknesses, and also help shift from the defense from reactive burden to proactive efforts. And also remember, a bug bounty program can be a very, very powerful tool if it is properly managed, because you have to realize it is a continuous process. Because as your attack surface is constantly changing and evolving, so too must your bug bounty provider, because you have to keep up to date all of these engagement briefs, terms of service, in scope, out of scope, all that stuff. Also, it is a huge win if you incentivize good reporting. It saves so much time for everyone. So you have to do it really, because otherwise this triaging will be very inconsistent, and you won't make optimal decisions probably. And also, you should explore and implement all of the useful capabilities that the provider offers, which is right for your program. You should consult with your provider and highlight problems and discuss how they can help you fix these problems. You should understand all of the features, integrations, and services that the provider offers to understand what works for you and what doesn't. And basically, just find what works for you and implement it. Because remember, it's not just about finding bugs. It's about building a human firewall. Thank you. Thank you for listening.
If you have questions, we will pass the microphone.
So, are there any questions, by the way?
Yes. Can you hear me?
Yes.
I can hear myself as well. So, would you say this BBP is viable? Should be considered only by large enterprises such as Bolt, or if I have 2 or 3 applications that I'm developing and hosting, would that be an option for me as well, or is it like too much of a hustle to take up?
Mm-hmm. Okay, that's a great question. I would say that a bug bounty program makes sense if your attack surface is big enough and you can't feasibly cover everything that you're trying to put out there. So if it's only a couple of applications and if you know all of the endpoints and you know your system, and if it's a small thing, then I don't think it makes a lot of sense, because also, as I mentioned, the bug bounty program is a living thing and it has to be taken care of. So, because if it's neglected, then yeah, it will not produce great results. And also, it is important that your company is relatively big, because these researchers that get on it, there is more chance that they will come onto your program if they are aware of your service, right? So if it's a small thing and it's not really applicable for them, then maybe it doesn't make sense. I hope that answers your question.
One, two. Can you hear me?
Yes. Yes.
So it's quite a simple question, but how many people from your side is actually managing all of this program? Because I assume the board is has a lot of people in security, and you have full-time employees who are actually maintaining, managing tickets and all of that stuff. So how many people it usually takes to run this program effectively?
Okay, so our product security team consists of only 4 people, and my responsibility is the crowdsourced vulnerability management. Manage the communications with the provider, look for improvements, and also solve the operational overheads. So it's on me, basically. I don't want to delegate to others if I feel like there are more improvements to be made. Anything else? Any questions?
If we don't have any more questions, then let's make another round of applause to Allar. Thank you. We have a little